So like I was saying, today and tomorrow are going to be proofs, and tomorrow's homework is probably one of, if not the hardest homework of the year, unfortunately, the day before MEA, but hopefully you can get, we don't go over a lot tomorrow in class, so hopefully you can work hard during class and get some of your questions answered. So, we're gonna skip over this ruler postulate, cause that's not something that you'll see again. And we're gonna go right down here to the segment addition postulate. So in these proofs today, and some of these pages, of course, you don't have, but anything that you need to have for the next quiz is going to be on your cheat sheet unless I tell you. So like this segment addition postulate should be on your cheat sheet. But this is something that we use a lot in this chapter. So what's gonna happen is they're going to give you a segment. And the rule is anytime you have 3 points on a segment, you can break it up into parts. So today, if you get a proof and you have something like this and you get stuck, one of the things you can do is break it up into parts. And what you do is you say this plus this equals this. So say, I'll just write it over here. So your reason would be segment addition postulate. So any time that you do that, and I should also write this, you would write AB plus BC equals the whole thing, which is AC, okay? So this is what you would write for breaking it up into parts, and then this would be the reason, something we do a lot in this chapter, okay? Bless you. So I'm gonna just go over a couple of things. This page I don't think you have in your notes, but this should be in your note packet. So we talked last week about definition of congruent segments, and there's times in these proofs that we either have to take the bars and squiggly off, or we put the bars and squiggly back on. Either way, what we call that is definition of congruent segments. Now, there's gonna be times in your proofs today and tomorrow that you get stuck, and I have some hints for what to do when you get stuck. One of the things is if it has bars and squiggly, take it off. And then the other thing is the segment addition postulate that I just showed you, that if you have a segment A, B, C, you can do this with any segment that has 3 points. You would say this plus this equals the whole thing. It would look like this, and our reason would be segment addition postulate, and that's how I abbreviate it. So when you first get started on geometry proofs, never would every single one in this class catch on immediately, know what to do, be able to do proofs on their own right away. You might see, just by answering questions, some kids might catch on faster, but no one's gonna be able to do it right away, okay? Or I shouldn't say that. Never would the entire class be able to do it. I would say maybe 10%, 5% catch on quickly. The others, it takes a while, okay? So when we get stuck on a proof today, there's 2 things that we can do. We can take the bars and squiggly off. When you are doing a proof, every step that you do is 2 points. So if you're on a quiz and you're like, I don't know how to do this, just taking those bars and squiggly off is 2 points. Then if you have a segment that has at least 3 points, you can break it up into parts, and that is segment addition postulate. And then what this says, and I'll talk about it as we get to one, you always want to look at your proof statement in the proof and look at what am I trying to get, and use that and substitution to get to that proof statement. So I talked about this. Now this right here is a proof. This I think you do have on your sheet maybe. This is a proof. This proof was taken from a textbook, and every geometry teacher kind of has a little bit different with how they do their reasoning. So you're going to see that I changed a few things here. So this says we want to prove if this and this, so those are our two givens, then this. Okay, that's what I'm trying to prove. Now, when I'm doing these proofs, one hint I will give you, if I am giving more than one thing, I don't write them side by side. I write one underneath the other just so that one of them doesn't get lost. Okay, so we wrote that down and it's given. Our diagram is this right here, and we're trying to prove that this whole segment is congruent to that whole segment. That's what we're trying to prove, okay? So if you notice what they did here, what did they do from here to here and from here to here? They took off the squiggly and the bars, okay? And I call that definition of congruent segments. So I would write this like this. So we have one for definition of congruent segments and one for definition of congruent angles, okay? That's one of the things you can always do when you're stuck. The second thing that you can do when you're stuck is segment addition postulate. And what that is, notice we have two segments that have 3 points. And so we can break that into parts. So what I can do for this is I can say CE plus ED equals CD. And that's what they did right here. And that is segment addition postulate. Okay. Now, if you notice what they say here for step 4 is they did substitution. Now, when we write substitution, we just write property at the end. But this book has the kids say, where did they substitute? And they're saying they substituted between steps 2 and 3. I don't make you guys do that, okay? So what they're saying is how they got from here to here is with substitution. So what that means is they changed CE to FE. And you have to look up above and see, could they do that? And they could, because CE equals FE. So it's like they picked the CE out and put FE in there, okay? Then notice they changed ED to EG. And they can do that because these two are equal. So it's like they picked this out and they put EG in there, okay? So they did that, and we would call that substitution property, okay? Now, if I was doing this proof, I would do both my segment addition postulates together, but the book did it separate, which is fine. So what they did next is they separated or cut the other segment into parts. So they went FE plus EG equals FG. Remember, anytime you have a segment with 3 letters on it, 3 points on it, you can break it into parts. So that is what they did right here, and they called that segment addition postulate, okay? Now what we have to do is figure out, how did they get this? Okay, how did they get from what we have? And with an algebra proof, if you guys remember, you always just went up one step and you were like, okay, what did they do? Did they multiply? Did they divide? Did they add? With a geometry proof, sometimes you have to go up several steps to try to figure out what they did. And if you notice this one, do you guys see how CD is this and FE is that? Aren't those two identical? Do you get that? So what they can do then, because CD equals this green box, and I have another green box here, I can pick that out and put CD in for that. And that is what they did right here, is substitution, and like I said, I would call that property. Those of you that aren't even watching, not a good day to do that, okay? This is something you have to know how to do, and we're doing more proofs later on this year, so today is not a day to not pay attention. Okay, now, do you guys all see what I did here? Does that make sense? Okay. Now, what did they do from this step to this step? They added the bars and the squiggly, and again, that's definition of, and I write it as congruent segments. So again, different books have a little bit different way to write their reasoning, but I just wanted to show you that one, okay? So let's go to this. First of all, if you guys notice, I have a segment that has 4 points on it. What that means is I can split P, Q, and R into parts, but I can also split Q, R, and S into spots, or into 3, or do segment addition postulate there. So I have 2 different groups of 3 there. So let's see how we do. So our given is this. So on our blank, I write given. Now, once you guys get good at proofs, you're probably not going to do it how this one is done. But do you guys notice what they did from here to here?
They just added QR both.
They added QR to both. Very good. They added QR to both. If they added the same thing to both sides, what do you think that's called? Addition. Just like if we added 5 to both sides. So that would be addition property. Okay. Now, another thing I can tell you guys is in today's proofs and tomorrow's proofs, if you say 2 things added together to be 1, you want to think about segment addition postulate. So if I look here, I have PQ, QR, and PR. So here's what they're saying. PQ plus QR equals PR. What is that called?
Addition, postulate,
Yep, you're right, but there's a word in front.
segment.
Segment addition postulate. Whenever you have 3 points and you break it into parts, it is called segment addition postulate. Now, if you notice, they did both of these under the same step. And so what they did is they also broke up segment QS up here. So if I look at that one, what they did is they said QR plus RS equals QS, okay? So not only did they break up PQR, they also broke up QRS, and this is what they got when they did that, okay? Now, here's the thing. I have to decide how they got this, okay? And I'm going to give you guys a hint. On these proofs, if you're on a test and you ever have to guess substitution property. for two reasons. One is, especially as you get down in a proof, we use substitution a lot. Second thing is, substitution is probably the hardest thing to see, okay? So we have to decide, how did they get PR here and QS here? Can anyone see what they did? Okay, so here's what they did. Do you guys see how this and this are identical? Okay. Do you get if PR equals this pink box? I could pick that pink box out and put PR in there. Do you guys get that? Okay. PR equals the pink box, which is identical there. So I can pick that out and put PR in there. Now, see how QS is this? Isn't these two blue boxes identical? And because QS equals that blue box, I can pick that blue box out and put QS in there. And that is what they did, okay? And if you had to guess on this one, and you guess substitution property, you would be correct. So if you get stuck on a test, do substitution, okay? All right, now let's look here. Okay. First of all, do you guys understand if you have 4 points in a line like that, do you get that you could break up JKL and you could break up KLM? Everybody understand that? Okay. So let's go ahead and start this. And we have JL, segment JL is congruent to segment KM. And that is given. Okay. Yeah. Yes. So what you're going to do first is take off the bars and the squigglies. Okay? So let's do that. So we're going to say JL equals KM. And do you guys remember what that's called? Yep, definition of congruent segments. And that's how I write it, is like that. Okay. Now, when you get stuck on a proof, first step, I have that on your cheat sheet. Take your bars and squiggly off, and we did that. What was the next thing? Very good. Segment addition postulate. And do you get that I have 2 of them here? Yeah. Okay. So I can say JK plus KL equals JL. Okay. JK plus KL equals JL. And that is segment addition postulate. Now, because we have another group of 3 points, I can also break those up. So what do you guys think we would write that time?
KL plus LM equals KM.
Very good. KL plus LM equals KM. And you can put those both under the same step if you want to, or if you wanted to do step 4 and say segment addition postulate, that's fine too. Okay? Now, because we know those 2 things, this is where most of you will get stuck. And honestly, I don't think you should ever come up to me until you get to this point. Okay? You all can do the given. You all can take the bars and squiggly off. And if there's 3 points in a row, you can all break it up into parts. This is where it gets tough. And if you guys go back and look at what I said on that first page, we took the bars and squiggly off. We did the segment addition postulate. This is where it's tough. it says for step 3, look at what you're trying to prove and use substitution to get the proof statement. So if I go back to where we are, okay, what I eventually want to have true, you guys, if you look, is I want this to be this equal to that. That's what I eventually want. Okay? So, anyone see something we can do? Say that again. It is, but we can't do that yet. You are right, but that's just a step or two ahead. Think about what can we substitute? What could we substitute in for something else? Do you guys see this right here? That JL equals this and JL is here. So couldn't I take, because this purple box equals JL, I can pick that JL out and put this purple box in there. Do you guys get that? JL equals the purple box. JL is right there, so I can pick JL out and put that whole purple box there. Now, notice how I have this. And KM equals this yellow box, and there's KM right here. So do you guys get that I can take KM out and put this yellow box in there? Right? You guys get that? So now I'm going to write down what we would get when I do that. So again, I put the purple box here. So I'm going to copy that purple box down, and you're going to want to write kind of small. JK plus KL equals, and then this is what I put in, the yellow box I put in for KM. So I want to write the yellow box next. And do you guys get what I did there is substitution? I picked the JL out and put the purple box in, picked the KM out and put the yellow box in. So my reasoning here is substitution cross. And just a reminder, guys, when you do substitution, make sure you have the ST on it, okay? And include prop. All right, now we're back to what Tegan said. Don't we have a KL on both sides? Do you think we can just subtract that away? Do you guys get that? So what we would do next is we would just get rid of those KLs on both sides, and we would say JK equals LM. And how I did that is I subtracted, so I would go SUBTR prop. Remember the difference of how you abbreviate this, yep? For the last step, don't we just have to do the definition of congruent segments and put the bars and squiggly back on? That is correct. So we would go segment JK is congruent to segment LM, and that is by definition of congruent segments. Okay. And honestly, you guys, do I think today you'd be able to do this all by yourself? Probably not. But between asking a friend, between looking at my key, between asking me questions, like if you can tell once I'm explaining to you kind of what is going on, that's important. And if you still can't do that, that's okay too. It should come to you as we go through. So I'm going to just go through this again. Midpoint theorem. We talked about this last week also. If M is the midpoint of AB, that means these two pieces are equal. If you were doing this in a proof, okay, this would be given that M is the midpoint of AB, and then you would go up to your diagram and you would say segment AM is congruent to segment MB, and that is by midpoint theorem, okay? But here's something I have to show you, is that when you have a midpoint, there's two different reasons that you can use. And the difference is, if you notice, if you say A, this one actually, this is a typo. Do you guys want to do this on your cheat sheet? Change this to X. I just have a typo there for that. I think this is on your cheat sheet. Okay. All right. So if you have a midpoint, that means these two pieces are congruent. And there's two different things you can say. You can say the segments are congruent, and that's midpoint theorem. Or you can say the measures are equal and not do the squiggly in the bars, and that's definition of a midpoint. When I first got started teaching, I was really picky about that, and I made kids do the correct one. And honestly, now I'm okay with whichever one you use. Whether it has bars and squiggly or whether it has equals, I think I always use midpoint theorem, either way, okay? And I wouldn't mark that wrong if you guys did. So I would probably, if I were you, just always use midpoint theorem and then don't even worry about that one. Sound good? Okay, whether it has a squiggly and a bars or not, we'll just use midpoint theorem. All right, so let's go here. This is just showing us that congruence is reflexive, which means a segment would be congruent to itself. Symmetric was that switch around property, and that works with congruent segments. And then transitive, if you remember, was the ending of this and beginning of that are the same, and you can cross those out and say those two are congruent. So there are going to be a couple like that on your sheet today and tomorrow too. Okay, when we look at this proof, you guys, there's three givens. There's this, and this. If I was writing the proof, I would do three, like kind of one on top of the other. And when I write it here, that's what I do also. So I'm going to say X is, I do MIDPT for midpoint of SY. And then Z is midpoint of YF. And XY equals YZ. Okay. And this is, oh, not number 2, sorry. These are all given. Okay. Now, I think what I'm going to do first, when I do the midpoint, there's two different ways I could do it. You'll see up here that eventually we do need to put the bars back on. So maybe I should do that first. Let's put the bars and squiggly on this, okay? So I'm gonna go step 2, and I'm gonna just put the bars and the squiggly on this. What is that called when you have to put the bars and squiggly? Midpoint theorem. Oh, no, definition of, sorry. Definition of congruent segments. Okay. Now, when you see midpoint in a proof, that tells you automatically you have to do midpoint theorem. And we have 2 midpoints, so we have to do 2 midpoint theorems. Okay? First, they're telling us that X is the midpoint of SY. Do you guys understand that would mean those two pieces are congruent? So what we would say is SX is congruent to XY. SX. SX is congruent to XY. Okay? That is midpoint theorem. Okay? Now, the next one is that Z is the midpoint of YF, so that would mean this is congruent to that. Okay? So I could say, now this is a different, I use 2 bars for these because these are different segments, but I'm going to say XZ is congruent, or was it YZ? YZ is congruent to ZF. YZ is congruent to ZF. Okay? And that's also midpoint theorem, so I can keep it like that. Okay? Now, what we want to do here is look at where do we want to go with this, okay? And where we want to go with it, you guys, is we want ZF to be congruent to SX. ZF, we want to be congruent to SX, okay? So we're going to need to use substitution. So we're not going to break up, when you have midpoint theorem, that doesn't mean that you always have to break up the segments. We eventually want these two to be equal. Do you guys see how SX is congruent to XY? I can take this and substitute it in there. Do you guys get that? Yeah?
So, it says up here, XY is equal to YZ.
Did I write that down wrong?
Never mind.
Here. Okay. All right, now what we're gonna wanna do, guys, is ZF is congruent to YZ, which is right here. So I can take this and substitute that up there. So because SX was congruent to XY, I could pick that out and put SX in there. Because ZF was congruent to YZ, I can pick that out and put ZF in there. And so what I can do then is say that SX is congruent to ZF. And what did I do there? Substitute it. So substitution prop. And is that what we wanted? Not quite, right?
I'll switch them.
I have to switch them around, and when you switch them around, it is symmetric. Very good. So, the last step I have to do here is switch the left and right sides. So I'm gonna get ZF is congruent to SX, and that is symmetric property. Okay. All right, one more. Okay. So, when you look at this one, notice there's 3 givens. Now, if you or I were doing this proof, we would do steps 1, 2, and 3 as given. But when we look, notice JK is congruent to KL, that's number 1. So I'm gonna put given here. And then, instead of putting the second one down, they put the third one down. That's because they know where to put them for a certain thing that we're gonna find. You and I would never do that. We would just write those 3, and in fact, I usually write them all under number 1 and write given. But they wrote this one second, and we're gonna write given. And then where is that middle one, the HJ one? 4. Okay, like I said, you and I would never have that. Okay. In a geometry proof, when you're looking at this, you're not just looking at one step ahead. Like in this step, I would look at both of these and see if you figure out what they did. Starts with a T. Transitive property, very good. The ending of one and beginning of the other are the same. You can only subtract, Dylan, if it was added on both sides of the equation. So this is different. Those are the same. We cross those out and it's transitive property. Okay. Now, does anyone see how they got step 5? Didn't they do transitive again? Do you guys see that? This is HJ, this is HJ. So they crossed those out and got JK as congruent to GH. Transitive property. Okay? And then the last one is symmetric prop. Okay, so you guys have a worksheet, and I actually typed it up separately for you and made copies for you, so you don't have to write these out. You can thank Brenda for that, because she was telling me. Brenda's right here in yellow. She was telling me how much easier it was. So, you guys can all bring me chocolate tomorrow to thank me. No? So this is your worksheet, but we're gonna do one together. And then, yeah. Yes, listen to this. Oh, no. Yes, listen to the one. Yes. Okay. I changed things. Okay, first of all, you guys, you have to pay attention still, so don't be doing anything. Okay, first of all, I have one mistake on my worksheet. So if you guys would all look at your worksheet, go to number 7. And do you see where there's a prove statement? It should say, let me think about this. Segment CD, I'll write it up here. Number 7 should say segment CD for the proof statement is congruent to segment AB. So this is the proof statement for number 7. That's a typo. Okay?
Why would it be that? Because didn't we just take off the steps?
Yes, but this is just a longer way of doing that. So yes, you're right, that could have been if it was that could have been a one-step proof. But you just have to follow what they did and give reasons. For the proof. All right, guys, we're doing one together, so listen up. Actually, it is number 10 that we're doing. Is that what I said? Yeah. Okay, let's do number 10 together. Listen up. Okay? So I thought this one was kind of hard. So because of that, we're going to do this one together. So on your worksheet, if you want to fill this in for number 10 as we go. Okay? So, do you guys see how there's 3 givens? Do you all agree you'd write them right here and just put given, correct? If this is on a quiz, you guys, every blank is 2 points. So the more you can get down, the better off you are. Even if you have to guess, you're better off doing that than leaving it blank. And if you really want to give me a heart attack, don't do the given. I get so mad when kids don't write down the given. Oh my gosh. It's 3 points. Please write down the given. 3 points. All right, everybody understand the given? We're all good there?
Yes, ma'am.
Okay. All right. So now what we have to do, once we get that given down, is try to see how did they get step 2? Yes, they took off the squiggly and they took off the bars. Boys, I would be paying attention.
Where'd my pencil go?
Congruent segments. Okay. All right. Now, do you guys see how it says definition of a midpoint here? Remember, I just told you guys, you could think of this as midpoint theorem. I probably should have wrote it as that. Okay. But definition of a midpoint and midpoint theorem are the same. But you know why I did definition of a midpoint there is I didn't want to put the bars on. So let's do it without the bars. That's why I left it as definition of a midpoint. So if B is the midpoint of AC, do you guys understand that we can say AB equals BC?
Yeah.
Okay, so let's write that. AB equals BC. And if E is the midpoint of DF, do you guys get that this and this would be congruent?
Yes, ma'am.
So we can say DE equals EF.
Oh.
Okay, yeah,
Not gonna lie, I didn't see second line.
very good question. Okay, the reason we did not add the bars in this case, Is- oh, I see what you're saying. That's a really good question again. That's a really good question too. When you have midpoint, you don't always have to break it up into parts. Every once in a while you do, but in this case, it doesn't look like we're gonna have to. So if there's midpoint, you wanna think more of midpoint theorem or definition of midpoint. Okay, that's a really good question though. Okay, guys, we have to notice here, how did we get from this to here? And are you just guessing substitution or you actually see it?
No, I see it. I'm guessing.
You, at least you're honest,
You
right?
told us.
Yes, and you're right. If you have to guess it. But do you guys see how AB equals BC? Didn't they put AB in there? And do you see how DE equals EF? So they put that in there. Get it? So that's substitution prop. Okay. Now you have that BC equals EF. Oh, you guys, I lied.
Oh, it's best 5.
The first step, I did 2 steps in one. The first step, they just put BC in for AB and got this. The second step, they did the yellow in for the DE. So they did their substitutions in 2 steps. So this is substitution again. If I was doing this proof on my own, I would have just done 1 step and substituted them both at the same time. Yes. So the last thing, if you look up at what you're trying to do, is put the bars and squiggly back on. So we would go BC is congruent to EF, and it's definition of congruent segments. Let me say one more thing and then I'll be quiet. If you were on a quiz, here's another way to get free points. Whatever this is, you guys, is gonna be the last step of your proof. Okay, do you get that? You don't write prove on this step like we do for given, but whatever you're trying to prove is always going to be your last step. Okay? There is a key to this worksheet on Schoology. Do it yourself first and struggle with it. Don't just copy the answers. Okay?